Okay, so lesson 3, still in chapter 12, still talking about motion. So far, you've learned about speed and velocity and acceleration and momentum, and you've done some readings about forces. So today we're going to be talking more about forces and how they affect motion. So the first thing is defining what is a force. Well, a force is just a push or a pull. Now, I know you're probably just visualizing somebody pushing or pulling something then. But essentially, it's a force is just something that can affect the motion of something else. So it can change the motion, it can keep something still in motion, right? So it's not just pushing or pulling, but those pushes and those pulls can be equal to the point where there's no motion happening at all. And that's where we get the idea of net force. So, net force is basically the overall force acting on something. So, for example, let's say you had two students standing side by side. And let's say that the students are about the same height, about the same weight, and had the same force that they were exerting, right? Both of them are pushing the box in the same direction, like standing next to each other, pushing it. Then that force pushing it is greater than the force going against it. That means that the net force is going towards the right in this example, right? Causing some motion. That is an unbalanced force. When the force in one direction is greater than the force in another direction, it's unbalanced. This is an example of a balanced force. Now let's say those two students stood on opposite sides, and again, they have equal force, we'll say. Now one's pushing one way and one's pushing the other way. There's still a force. There's still a push and a pull happening here. It's just that they're equal in magnitude, which creates no motion and the box is actually still. So the net force is 0, even if the force of each student was like 5 newtons or so. The unit we use for force is newtons. You don't need to know too much about that right now, and that's just the force. So like inches, it's newtons. We use a capital N. So next thing we'll talk about are some laws that are related to motion. So remember we talked about Newton before when we talked about Newton's law of gravitation. And now we are going to be talking about 3 laws from Newton that are all related to motion. So the first law, which we call Newton's first law of motion, is also referred to as the law of inertia. Remember inertia from when we were talking about planets? Inertia is the force that keeps it from pulling into whatever it's orbiting. So for example, if we had the sun, I'll label it S, and we have the earth, right? And we know this is gravity pulling it towards the sun, but that inertia is what's keeping it moving around. So basically, inertia is a force that makes something want to resist the change. So according to Newton's first law, any object that is at rest, meaning it's not moving, will stay that way unless an unbalanced force acts on it. And that makes sense. If you have a ball sitting on the ground, unless something kicks it or causes it to roll, it's going to stay sitting on the ground. Same thing, something moving at constant velocity is going to stay that way unless an unbalanced force acts on it. So if the ball starts rolling down the street, it's going to keep rolling until like friction or air resistance or someone's foot stops it from rolling, or someone kicks it even further and it continues rolling at a faster speed. That is the first law of motion. And again, just defining for you what inertia is, it's the tendency to resist any change in motion. So the second law of motion has some math related to it. This is attached to acceleration. Remember, acceleration is when you change velocity, so you can either change the speed you're going or you can change the direction you're going. And that could be speeding up, that could be slowing down. So change in velocity is acceleration. This relates a force to the mass of an object and the acceleration of an object. And there's a formula we use to basically explain the second law of motion. And this is that formula. It can be written one of 2 ways because remember with algebra, we did this in math. You can kind of move things around depending on what you're solving for. So sometimes the second law of motion is written like this. The force equals the mass of the object times the acceleration of the object, because obviously the more force you have on an object, the faster it's going to go. So if you have 2 balls rolling down a hill, right? If one's just rolling and one's kicked, the one with the greater force, when it's kicked, is going to roll faster and further, right? But let's say that both of them were kicked, but one was heavier than the other one. The heavier one's going to roll faster down the hill because it has a greater mass. So acceleration, mass, and force are all related. If you're trying to solve for force, it'll be mass times acceleration. But again, we know algebra, so if we want to solve for acceleration, we would divide both sides by m. That's how we get this. If we want to solve for mass, we would divide both sides by the acceleration, and we would get this, right? But they're all the same thing. They all are just used to show that there's a relationship between force, mass, and acceleration. So here's a problem for us. You push a wagon that has a mass of 12 kilograms. If the net force of the wagon is 6 newtons, remember I said that unit for force is newtons, what is the wagon's acceleration? So we're looking for what is the acceleration. Remember, whenever you get these word problems in math or science, always remind yourself, what is the question asking you? I underline it so I know, okay, that's what I need. That's what I'm looking for. That's when I know I have my answer. So we know this is Newton's second law. And if I want to solve for acceleration, do a little algebra here. You know how to do that. Cancel out that m. F over m is going to equal a. They gave us the force. That was 6. They gave us the mass. That was 12. So 6 divided by 12 is the same as 1/2, or I love my decimals, 0.5. There you go. That is your acceleration. So lastly, Newton's third law. Newton's third law of motion states that basically sometimes this is also called an action-reaction force. That if one object is exerting a force on another, then that object is also exerting a force on the first one. So think like two people pulling on opposite sides of a rope, right? They're both putting a force on each other. If you kick a ball, you're putting a force on the ball, but the ball is also putting a force on your foot. Now, one can be greater than the other, but there is a force exerted. And so we call that action reaction. Sometimes for every action you do, there's some sort of opposite reaction. And there you go. That is force and motion. That is the end of lesson 12.3.